All right. So substitution, replace X with whatever is in the parentheses. So on 1C, substitute and simplify. Focus. Focus. So the function g of x is the square root of x plus 12. So whatever you replace the x with in g of x, you're going to replace all the x's with the same thing. So in number 1c, you're replacing this x, replacing it with x minus 8. So that single x is now x minus 8 instead. So this x right here is an x minus 8. You're replacing a single term with a binomial, two terms. It's not a bad idea when you're making a substitution like that. It's not going to make a big difference when it's the very first thing, but when it's the second thing, especially if you have subtraction. So good habits always help. Use parentheses when you make that substitution. I'm replacing that one thing with this quantity, that expression. So g of x minus 8 is now still a square root. This x is parentheses x minus 8. And then the rest of the function is plus 2. Then you're supposed to add 2 to it. So now when we simplify, and this is a common mistake that was made in the Tuesday, Thursday class, and I think one or two people made it in here. This is g of x minus 8. Now it was x plus 2, not times, addition. So it's the square root. Order of operations, you're supposed to simplify x minus 8. So we did because there's no like terms. So you can drop the parentheses, but this is plus 2, not times 2, so it's not distribution. Thank you very much. That would be different. So it's that x minus 8 and then you're going to add 12. So under the radical, so we're still under the radical. Simplify what we have. We have g of x minus 8 equal to a square root. Combine like terms, only one term is an x. And then you have a negative 8 plus 12, and that's positive 4. Now the square root only does perfect squares. This is not a perfect square. And you cannot separate addition with a radical. You can't go square root x plus square root of 4. So the answer is just the square root of x plus a 4. Done. So think about what the answer was for 24. 24 plus 12 is 36. So that was square root of 24 plus 12. That was 36. So square root 36. And that was a 6. Okay. X minus 8. What number, take away 8, equals 36? Well, not it. I want 24. What number, take away 8? I want to try 24. What number take away equals 24? What would x have to be? X minus some number of 24. 32, because you add 8. And we get x equals 32. So right here, if you actually plug in g of 32 minus 8, that's g of 24, isn't it? So the answer better be 6. Over here, I'm replacing the x right here with a 32. So right there I go 32 plus 4. And there's the square root of 36, and I get 6. So this is just a way to write if it's, and you got to understand what's going on here is if we shift a graph left and right, then what the graph will end up looking like is this. This is going to move the graph 8 units to the right, but because of the plus 12, it actually only goes 4 units to the left. And that's going to take us into section 1.5. When you start moving graphs left and right, transformations of graphs, okay, left and right, up and down, we have to understand how it moves. You mess with the x's, you're shifting left and right. You mess with the y, you go up and down. Okay, domain. Now this is where I can tell right away, and again in Tuesday, Thursday, students were confused with what they thought they heard I said with what I actually said. What you thought, some of you thought I said was that the x cannot equal 0. X can't be 0. If you have a denominator, x can't be 0. That's not what I said. Right here, if I plug in 0, make sure I'm on camera. And I need to move the chair down because I can't see the screen. Cool. If I plug in 0, h of 0 is 2 times 0 plus 3 over 4 minus 9 times 0. So h of 0 is 0 plus 3 over 4 minus 0. So h of 0 is 3 over 4. When you plug in 0, we get an answer. It's defined at 0. What you can't have, when you're dealing with domain, you can't have the denominator equal 0. You don't care about x, it's about what the denominator can be. And you can't have an even root of a negative. So this has an x in the denominator. That means this denominator, the 4 minus 9x, cannot equal 0. And I'm going to be honest with you, domain questions used to just vex me, and anger me when I was in master, all the way through college. And professors always ask domain questions. Why? Because you have to think. We're not asking you what's the answer. We're asking you what values of x can we plug into this function so that the function is defined. So how do you go about it? You basically have to figure out what's the answer and then think, if that's the answer, how do I rewrite the domain using that answer to establish what we can actually use? So here's the deal. Because it has a denominator with an x, that means there's a potential of the denominator equaling 0. And if that's the case, I need to figure out what would make the denominator 0. So I can do this. What would make the denominator 0? And then that's what I can't plug in. So you're trying to answer a basic question and then use that answer to actually almost write an essay, to think it through as an essay. And okay, this is math. But that's what a domain question is really like. We're not asking what does X equal, we're asking what can X be. So what can we not use? And if we figure out what we can't use, then we know what we can use. Okay, so that denominator can't be 0. So let's find out what makes it 0. Subtract 4. Negative 9x is equal to negative 4. Divide by negative 9. So the denominator equals 0 if x, negative over negative positive, if x is positive 4 over 9. Which means we better not let x equal 4 over 9, because if I plug it in, I get 0. So if you drew, and here's the nice thing about pictures. What just happened is here's 0. The domain looks like this. Here at 4 over 9, there'd be an open circle. So the domain would be everything except, you would shade the number line, everything to the left and the right. That's what you can use. Any real number except that open hole at 4 over 9, you can't use it. So now for the interval notation, and interval notation is always left to right. So down there at the very far left is negative infinity. And it's always parentheses on infinities. And it goes all the way and stops at 4 over 9. So from negative infinity up to 4 over 9. And because it's an open circle, it's not equal to it. If it's not equal, parentheses. And the next set of the domain starts at 4 over 9, but it doesn't equal it. If it equaled, it would be a solid circle and we'd use a bracket. So it would be a parentheses, and it goes from 4 over 9, and it goes all the way to positive infinity. And the last little, final touch you got to put here is, it's the union of those two sets. You join the two sets together, and that union of these two intervals, everything from negative infinity up to 4 over 9, but not including 4 over 9, join together, union, this interval from 4 over 9, but not including 4 over 9, all the way to infinity. That's what I can use for the domain. And the interval notation is how you write this domain mathematically, using mathematical notation. And that's what we're here for, just to learn how to do the math. I put up the 1.4 example that we're going to continue. I think we did this one, 1 through 6, we're going to continue. And I know I wrote it differently, I'm summarized it differently. That was, I know, I'm pretty sure we did 7 through 10 was the odd and even, odd and even. And we need to do 13, which is a calculated example. 17. We already did 25. 33, 37, 47, 49, 57, 49, 49, 7. Choose 59 or 61. Number 63, 65, 73. And then we're going to choose 75 or 77. And then do number 79. And then you got to choose 81, 83, or 85. And we're going to do number 93. And then we're going to do a walk and talk. Talk through 99 to 104. Which means I'm going to walk you through it, talk you through it. We'll probably, because there's really no work to do with matching.
So, the top 2x plus 3, I saw it, but I'm not supposed to.
Because we're not asking for the zeros. If I was asking, where does the function equal 0? So this is not going to harm the domain. 0 over a number, that's just 0. That doesn't change the domain. That has nothing to do with what we're allowed to use or not to use. That just tells us where it crosses the x-axis. So if we want the x-intercept, then we would want to know where does the function equal 0. So you would let this equal 0. And if you cross multiply both sides by 4 minus 9x, then 4 minus 9x over here, that reduces, you have 2x plus 3 equal to 0 times 4 minus 9x is just 0. So that's where you let it equal the numerator equal 0. And then when you solve, subtract 3, 2x equals negative 3 divided by 2. At negative 3 over 2 for x, that's where the function equals 0. Has nothing to do, that just means it equals 0, right? Has nothing to do with what the domain is like. Okay, the denominator can't have 0 in the denominator, can't have negative in the numerator.
I just plugged in 0 for x.
So yeah, plugging in, now what we're doing, it's what would make, so that idea of, I need to figure out what's going to cause problems.
That's what I did. I just tried 0.
And so you're not supposed to try it, not just randomly pick numbers, because you could do that forever.
Yeah.
And the number you picked, it didn't cause the denominator to equal 0. Okay, that's then, so we know how to solve equations, so that's why you just take that denominator and set it up.
Offer a fine for 1C. That's why I needed a drop percent for or drop
Right here.
if like from the top, like the first function down would it be incorrect just like jump from like 1 to
It's not because it's in front, but if the function was 12 minus x instead, this is where you might run into trouble. 12 minus, and then you plug in x minus 8. If you just go x minus 8 without a parentheses, you're not subtracting x minus 8. You're subtracting the x, and then you have a negative 8. If you need to subtract this x minus 8, you gotta subtract it as a whole. So the next thing you would get would be the square root of a 12 minus an x and plus an 8. Because whenever you subtract more than one term, you gotta distribute. Addition, it doesn't hurt it, because if you distribute adding, addition, plus, it doesn't change signs. But when you distribute a negative, it's gonna change the signs. So without the parentheses, it's not gonna be there. So I put parentheses when I substitute more than one thing. So I make sure I always do it when I need to do it. So just, again, good habits. Here, it's not going to be a big deal because it's the first thing. Oh my gosh. You know, when I sleep on my left side, this shoulder is really bad. And I get a pillow on the front of me, and I try to make sure I put my arm around the pillow and tuck my hand underneath the pillow I'm sleeping on. And every time I wake up, I'm on my back, and this arm is back up here. And then this shoulder is just so bad. Oh, it hurts so much. Don't get old. Well, if you're gonna get old, take care of yourself. Okay. So
as a sports, it was
I've been in, I believe, seven car accidents where the car's been totaled. And then a few others. Plus I played, okay, I sat on the sideline as a football player. But, you know, I practiced every day. So that messed me up. But the last car accident, major car accident I was in 2011. My back is really bad. I've got the discs started withering away, and so I actually had a doctor's appointment yesterday, and the neurologist said, "Yeah, we took the MRI, and you've got this, this, and this." And you know, I had degenerative disc disease, and the car accident just exacerbated. So, no, two of them were my fault, and that was, you know, years and years and years ago. I mean, I was just an idiot. You know, because I was upset about a girl, was one of them. And the other one was my friend and I were coming back from Hensley Lake after fishing, and right front tire blew out, and I overcorrected. You know, I think I was 16 or 16. So I had zero experience. But no, we hadn't been drinking. So he's now in an emergency room doctor. He got messed up because his arm was out the window and the car ended up on his side. And so he cut his arm up really bad. And somebody traveling behind us pulled us out of the car and drove us to Madera Hospital and slept us. But thank goodness, because he got his arm cleaned up and fixed up, and I think he got interested in medicine after that. Now he's an ER. I don't know. I can take credit. I'm not going to take credit. But you know, she says that my shoulder problems right now, I thought it might be my rotator cuff. I've had this one fixed twice, rotator cuff. I thought it would be this one because, again, as an idiot, I never played baseball, so I never warmed up properly. And I coached my son's team, and I would just go out there and mess around, and I just never warmed up properly, and I just would try to throw as hard as I could. So
warming up.
if you don't warm up, yeah, it messes you up. You will pay for it. But she says it's connected to my back, and the MRI shows it. I start physical therapy next week. Right. So just we can't do a couple of these yet because we have to just define something down here. But a function f is blank on an interval when for any two x's, x of one, x of two, in the interval, if the first x is less than the second x. Remember what I told you about that? When you look at graphs from left to right. So from the first x to the second x, the first x is on the left, the next one is on the right. If the y value of the first x is up here, and the y value of the second x is below it, see, f of x sub 1 is greater than f of x sub 2. So as we go from left to right, this y value is going from here, and then this one's down here. What's that function doing? Decreasing. Because the y's are getting smaller. Okay? But that's how you write it out using mathematical language. And it is precise. And that's what math is all about, being precise, not leaving it up to some interpretation of words. A function f is blank. Now, actually, we haven't talked about that yet. I'm talking about odd and even function. We'll do that.
What about number one, right? We said that was greater than, so. if
F of x of 1
greater than-
is greater than f of x of 2. So the first x, y value,
And if it was, let's say it was less than that.
so then it's going from here to there. So we'll talk about 2 later. The graph of a function is a segment. Is a segment. Definition of a segment is not a line that goes on forever, but is a point, solid point to a solid point, and it's a piece of a line. It has a endpoint, a beginning and an end. It's finite. A segment is finite where a line is infinite. The graph of a function is the segment that goes from 1, 2 to 4, 5, including the endpoints. So what's the domain? So if you drew a picture of this, 1, 2, whenever I hear that 1, 2, I'm thinking of Rolling Stones because they have a song. 1, 2. There's 1, 2. And then 4, 5. And it's just this segment. So they want to know what's the domain of this function. But that's all you have. So domain is your x's. Where did the x's start? You see something over here, 0? They start at x equals 1. When did they stop? They stop at 4. So it goes from 1 to 4, and it includes the endpoint. It includes it. So that means you have a bracket.
It was an open circle.
Then you have parentheses. Because it's only the numbers in between 1 and 4, but not 1 and 4. Here, because it includes the endpoints, if you wrote it using inequalities, all of these x's here in between are in between 1 and 4, but you also have equal to 1 and 4 as an inequality. We talked about the vertical line test, right?
Yeah.
Vertical line intersects a graph twice. Is that a function?
No.
No, that's 4.
So like, on the homework, we have to grade it. Since we know that it's no, you have to write that whole thing.
No, you have to write it out. The only thing you have to write out are when you actually have problems that you're solving. Let f be a function such that f of 2 is greater than x for all, okay, so we haven't talked about max and min. So we got to do max and min. And we got to do step functions. That's number 6. So we got to talk about 5, and 6 and 2. Okay. Seven and 10, we did domain and range, 5 and 0.
Number 5, that'd be relative to the next one.
We have, I wanted to find it first before I go.
Yeah.
Okay, 13 is just a calculator demo. So let's look at 13. We are supposed to use the graphing utility to graph the square root of x plus 2. So, square root. Inside of x. And then window. How should I set up my window? Well, you know you can't have the square root of a negative. So if I just set my window and let's just say, I know I can't be negative. So let's just go to 0, I don't know, 0 to 9. Because the square root of 9 is 3. That's a nice number. So 0 to 9, we'll make that a 1. And then we'll say, when I only know what the X window is going to be, I do a zoom fit. And it'll take care of my Y window. And as you can see, it doesn't look like I'm getting a complete picture. Because when you see this little dot here at the bottom, that's not the x-axis. Okay, this is just showing me that this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but it's not a solid line, so it's not the x-axis. So if I now open up the window again, I can see what the y's are. It's telling me the y's are 1.414 to 3 something. I know I should be able to take the square root of 0. Just can't take the square root of a negative. And this is important. When you're trying to graph square roots, you want to pick nice numbers. So when you plot your ordered pairs, you have nice numbers to plot. I don't want to graph 1.414. I don't. That's not very easy to plot correctly or accurately. I want to plot nice numbers. So when you pick values to plug into a function like this, what you want to get is perfect squares inside your radical. You want square roots of 0, which is just 0. You'd like to get the square root of 1, which is just a 1. The next perfect square is 4, because that's just equal to 2. So you want to avoid, you don't want to get square root of 2, square root of 3, because those are decimals. You don't want to get square root of 5, square root of 6, square root of 7, square root of 8, because those are not perfect squares. The next perfect square is square root 9, because that's just a nice 3, backwards, 3. The next perfect square after 3 is going to be who? Square root what? 16. That's a 4. I mean, look at the right side. 0, 1, 2, 3, 4. Inside here, 16. The next answer would be 5, so in here would be 25.
Is that really how it goes?
Yeah. Perfect squares.
So 6 and 36 and 7.
Yeah. So inside here, what plus 2 would give me a 0 inside that square root? What would make that x plus 2 equal to 0? What would I need to plug in for x?
-2.
Subtract 2. That's where I should start my x window. It should start from -2. If I plug in -2, f of -2, I get square root -2 plus 2 square root 0, I get 0. Remember, the inside cannot be a negative. It doesn't say x can't be negative. After you plug in x, your final, what you take the square root of, cannot be a negative. I could not plug in -3. Square root -3 plus 2 would be the square root of -1, and that's an imaginary number. We're not graphing imaginary. So I couldn't use this. I have to stay to the right of -2. So I should have started my x minimum from -2. And then my x maximum. Let's say I still want to go all the way to a square root of 9. So that means I want the x plus 2 in here to equal a nice 9. So if I want the x plus 2 to be a nice 9, what should the actual x be? I should take it to a 7. If I plug in 7, it's the square root of 7 plus 2, which is square root 9, which is going to give me a 3. I don't want the answer to be 9, I want the answer to be. So I want my x max to be a 7. And now we'll do what's going to do. There we go. So now I've got a better idea of the graph. It goes from -2, and it goes all the way forever, and it keeps on going out. Now, that's not really the shape of it. So that's what the window looks like. If you want the real actual shape of this thing. So, because look, this is 0, 1, 2, 3, 4, 5. And then this is 0, 1, 2. So it's not the scale, is it? The y's have a bigger separation than the x-axis. So then you do a zoom square. And that will even it up. And that's the actual shape of the curve. Now, what they want from us, after you graph it, use graphing utility to graph the function and estimate the domain and range, and then find the domain and range algebraically. So domain and range, again, it's going to start here from -2, and you can keep on plugging in numbers all the way forever. Because you keep on plugging in numbers to the right forever, you're going to get positive numbers in the radical, everything is good. You can't plug in something less than -2 because you're going to get negatives underneath. So the domain in this picture, all of the x's have to be greater than or equal to -2. So that would be a bracket from -2 to positive infinity. Because there's an equals on the -2, you have a bracket. And it goes to the right forever, so that's to positive infinity. Infinities are always parentheses. Now, range. The range, the y values. Does this graph have any y values down here below?
No.
No. This graph is going up. There's no y. When you put a little arrow over here, it's going to continue up forever. As x gets bigger, the y's keep getting bigger. There are no y values down here. So the smallest y value, that ordered pair right there, is -2 for x, 0 for y. The smallest y value is 0. So all of my y's are above the 0. That means greater than 0. And because when you plug -2 in, it actually equals 0, all of the y's are greater than or equal to the 0. Okay? Everything above the 0 or equal to 0. That's what this function equals. So the range, because there's an equal, it goes from 0 and greater than means it's going to go to infinity. There's my range. And that's using the picture. And that's what you do. So you ask yourself this question on the range. Where are my y's? Are there any y's down here? No. So where are my y's? They're above this y value, and right here, the y value is 0. And then they're above it. Above is greater. Does it equal 0? Yeah, that's a solid circle. It equals to 0. So all of my y's using inequality, all of my y's are greater than or equal to the 0. And then interval notation is this. Where are my x's? My x's go from -2 to infinity. It also equals -2. So all of my x's have to be greater than -2, and it also can equal -2. So that means -2 and then to the right. Now it also wants the problem algebraic. So if you're going to do this without a graph, again, here comes the thinking. That curse word that everybody despises in mathematics or in any class, think. So if I would have asked you what's the domain of a square root instead of that fraction, you would need to go, all right, domain. When you have radicals, you cannot have an even root of negative numbers. So what's inside a radical, an even root, has to be greater than 0, because that's where the positives are, or equal to 0. It has to be, and the word is non-negative. You can't just say positive. When you say positive, you're not including 0. 0 is neither positive nor negative. Doesn't have a sign. So the word is non-negative. So it means you just can't have negatives. It could be 0 or bigger than. So this x plus 2, what can it be? That x plus 2 can be greater than 0 or equal to 0 for the domain. That's how you set it up. What can it be? Subtract it. So my x's have to be greater than or equal to -2. There's my domain.
-1.
Yeah, -1. F of -1 is the square root of -1 plus 2.
Oh,
So that's the square root of 1. So that means right here, -2, because there's an equals all the way to infinity. And then you got to think range. So when you're dealing with range, you got to ask yourself, all right, what can square roots actually equal? Well, when you take the square root, just a square root, not plus and minus, but just square root, it's going to be positive only. When we say, what's the square root of 16? The answer is positive 4. But when you have square, x squared equals 16, and you're solving an equation, this is simplified. What's the square root of 16? 4. This is solved. We want to know what are all the possible answers that I can plug in for x that makes this equation true. You would take the square root of both sides, and you would get x is equal to 4. Because we want all of the answers, we would put plus and minus in front of it. It could be positive or negative 4, because we want all of the answers. But when you just simplify, it's just a positive answer. So a square root has to be only positive answers. So that means the y values have to be greater than 0, and a square root can also equal 0. So you gotta think it through. You gotta think it through. Therefore, equal to 0 means bracket, and then greater than goes to infinity. Here's my range. And you almost gotta talk yourself through it too.
You said y cannot equal 0? Or negative, sorry.
Right, yeah, because if everything is gonna be, there's no way I'm gonna take the square root of something in here and get a negative answer.
If there were negative.
Now, if there was a negative in front, then you take no. If there's a negative in front, if I go negative square root of 16, then I take the negative, bring it down, take the square root of 16, which is 4, and then simplify it as negative 4. Because it's on the outside. No, but it's on the outside. Negative square root of 16. It's like saying, what's the opposite of the square root of 16? So bring down the negative. This is a 4. This is on the outside, so it's a negative 4. So it's like, what is 5 minus the square root of 9? 5 minus, so order of operation. I'm supposed to do this before I can do the subtraction. Addition, subtraction is always last. So I bring down the 5, I bring down the minus, this equals 3. If it's on the inside, now that's not a real number because it's inside the radical. Right? When we get to 1.5, this graph was here at -2, and it went this way. This graph is the exact same as square root x plus 2, but every single answer that comes out here is going to be change the sign. So for every single answer that comes out, they're going to be underneath instead of above. And that's an always. If you put a negative in front of the function, it always flips it across the x-axis. If you have g of x equals positive x squared, that goes up. But if I have h of x equal to negative x squared, then it goes down instead. It flips it upside down. Okay. A negative in front of the function is always going to flip it across the x-axis. Okay. Thirteen. 17. Domain, range, and so. So on 17, A, B, and C, you're supposed to and I know you have A through I. Oh my God. Oh my God. It's like, that's like a, You gotta be kidding me. That's like 47 things I gotta do. No. You're just writing down the answers. And when you see a problem like this and it's got all those parts, you know what you do? You do one part at a time. And you breathe in between. Domain of the function. Now, you see how it doesn't, like, that's exactly 4, but I have no idea what's going on here and what's going on here. So what they really should have done when they made these pictures, they really should have put arrows on it so you would know that it's going to go on forever. So domain. On the x-axis, because this continually goes up forever, on the x-axis, we keep using x's forever to the left. And because that keeps heading in that direction forever, that means we're going to keep on using x numbers all the way to the right forever. Now, in between, everything has a point. Everything is nice and shaded in or solid. There's no open circles or anything, so there's no missing. Like right here at 3, if there was an open circle, that means you would not have plugged in 3, but everything is nice and solid. So that means the domain, we're using everything to the left and everything to the right. We're using the whole number line on the x-axis. The domain is negative infinity to infinity. And then think about it. Here's the function. Absolute value of x minus 1. And then a minus 2. Do you see a denominator here in this function? So that's not going to have any trouble with any denominators equaling 0. You see any even roots in this function? So there's not going to be any negatives in an even root. So there's nothing that's going to hurt the domain anyway. All real numbers. The range of the function. So there's our y's. So look at the picture. The very bottom of the function is right here when x is 1 and y is -2. Are there any y values below that? So all of the y's are above, so greater than -2. And because that's a solid point, it's equal to it. So the y's have to be to the right of -2 and equal, so bracket on -2, and it goes to the right forever, infinity. If you did that on a number line, y is greater than or equal to -2. On a number line, there's your -2. Because it equals, it would be a solid circle. And then on the number line greater than, you would shape everything to the right of -2. So that's a bracket, -2 to infinity. This is really good. Find the value or values, which means might be 1, could be more than 1. Find the value or values of x. We're solving for x. We want to know what does x equal. For which f of x equals 0. When does the function equal 0? That means, remember, what does f of x replace? It replaces y. When does y equal 0? That's the same thing. So in this picture, sorry about that, folks at home. When y equals 0, you're on the x-axis. Everywhere on an x-axis, the y coordinate is a 0. So right here, that y coordinate is a 0. And then one more time, that y coordinate. They want to know what are the x's. So what's this x right here when the y is a 0? -1, and what's this one? So they just want to know x equals -1, comma, and so don't put parentheses around it. And +3. You're just listing the two answers. If you put parentheses, if you go -1, parentheses, +3, you are saying that x equals 0 from -1 all the way to 3, except for -1 and 3 because it's parentheses. You're giving me an interval of numbers, everything in between. You're saying everywhere in here, the y is 0. So here you're just listing the two individual x values. So you gotta be careful. How do you know? What are the x's? What are the, each x? D. What are the values from part C referred to graphically? So that -1 and that +3. What's the name of them in terms of the graph? They're the x-intercepts. That's where the graph intersects the x-axis. They're the x-intercepts. Whenever you're asked to find the x-intercepts, you let y equal 0. Solve for x. Find f of 0 if possible. So that means you're going to plug 0 into the function. So that means you're supposed to let x equal 0. So when x is 0, everywhere on the x-axis, every point on the x-axis, that's when you have x is a 0. Right, I said that. Everywhere on the y-axis, the x is a 0. So where's the graph on the y-axis? It's right there. Right there, x is 0. So f of 0 equals this y value. So if that's -2, then what was this? -1. So f of 0 is -1. And what is that called graphically? Well, if these on the x-axis are called the x-intercept, guess what that's? That's the y-intercept. And if it is a function, you only have one y-intercept. Because if it intersects the y-axis twice, if you had two y-intercepts like this, then that violates the vertical line test and it wouldn't be a function. So if it's a function, you're only going to have one y-intercept. Y-intercept. Okay. And the reason why I'm doing this whole thing is number one, because I know you guys probably wouldn't. But number two, again, looking at it just one piece at a time. It's all words. And when students see a bunch of words in a math class, they know what. But when you just take it apart slowly and just answer the questions one at a time. What is the value of f at x equals 1? So what that means is what does f of 1 equal? What's the y value, the ordered pair, when you plug 1 in for the x? So when you plug in 1 for the x, what's the y value that comes out? -2. And then you know what? Hey, they told you this down here. They gave you the actual function. You could have gone, all right, f of 1 is the absolute value of 1 minus 1, and then -2. So that the absolute value of 0 minus 2, which is 0 minus 2, which is -2.
You do know the.
Yeah, you could done with E. Plug in 0 here. So what are the, so and look right here. What are the coordinates of the point? What is the value? So there's actually two questions here. Question mark, question mark. What is the value of f at x equals 1? So f of 1 is -2. And then what's the ordered pair, or what are the coordinates? X is 1, y is -2. H. What is the value of f at x equals -0? Mhm. Which we kind of already established right here at -1, that point right there. -1 goes in, the y is a 0. And then what are the coordinates? Well, -1 for x and the y is a 0. Now I'm going to show you two ways to do I. So if you already can think of my second way, then hold your tongue. I'll get to it. The coordinates of the point on the graph of f at which x equals -3 can be labeled -3, -3 for x, and then f of -3. That means you plug -3 into the function, and that's your y value. Or -3, and they want you to actually figure it out. Now, 90% of the time, students don't even see the function down below. So they're just looking at the graph. And you can see that this doesn't give you -3. There's -2, and you can kind of see that that's +1. And then there's not even a -3 here. But an absolute value is made by straight lines. Lines have slope. If we go this way, the slope, you're going up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. So right now, this is -1, 0. If I go up 1, left 1, I'm at -2, 1. And if I go up 1, left 1 again, I'd be at -3. And when I went up 1, I would be at +2. Just by following the slope established by the graph. That's the more difficult way. Because they give us the function, f of x is equal to the absolute value of x minus 1, and then take away 2. All you need to do is let x equal -3. F of -3 is the absolute value of -3 minus 1 minus 2. Always complete inside the absolute value first. So f of -3 is the absolute value of -4, and then take away 2. F of -3 is +4, take away 2, and f of -3. So that's how you can do it there.
So an absolute value. Can be negative.
After you complete what's inside, absolute value means distance from 0. Distance is always positive. So the absolute value of a positive number, +5, A 5 is 5 units away from 0, absolute value positive 5 is 5. The absolute value of -8, 8 is 8 units away from 0, so the absolute value of -8 is positive 8. Now, the absolute value of this, just x minus 1, you do not make it x plus 1, because we don't know what x is. That's an expression, not a number. It depends upon what you're plugging in for x, so that takes more pieces. Again, that's something that's covered in algebra 2. Now, whether you remember that or not, that's something different, but that's something that we probably are going to get at some point. All right. So now we have to talk about that. Ready to go, please? Yeah, we can still do 33. And we can do. And at 37, we got to go to the definition of maximum. 33. I want to show you how, because it says, use a graphing utility. And I want to make sure you understand how to punch in absolute values on your calculator. So 33, we want to take f of x equals the absolute value of x plus 1 plus the absolute value of x minus 1. And graph it, determine the open intervals on which the function is increasing, decreasing, or constant. Okay, so the absolute value is here under, and actually, I'm going to make this. Under math. So I'm going to type in absolute value of x plus 1 first. So I go to the math button. Click on the math button. So the math has 4 columns. Across the top, you have math, and then num, and group. So numbers, complex, probability. So if I scroll to the right, just 1 to the num, there's some basic functions that the calculator is going to do. The very first one is absolute value. The second one would be rounding. Okay, we need the first one, absolute value of x plus 1. So now I type in x plus 1. You have to close the parentheses. And then that absolute value plus the absolute value. So again, I'm going to go to math, scroll over to the right, absolute value. And then I type in my x minus 1. And then close the parentheses. And then I need a window. Well, I have no idea what to set my window to. So I'm going to set my window to just like maybe -5 to +5. Let's do that. -5 to +5, and the x scale is 1. And then I'll do a zoom fit. Oops. And there you can see I got those dots at the bottom again. So that's not the x-axis. I'd like to see what the x-axis is doing, because I'd like to know where my graph actually technically is. So I go to the window and see what is actually happening. And this is what is happening. The y minimum is 2, and it goes up to 10. So when you do a zoom fit, it is only giving you the y values that would happen when you go from -5 to +5 for the x's. It's only going to give you the y's that go with those x's. So the other y's that aren't showing up, they don't come out when you plug in -5 to 5. But I like to see what's going on below. So I'm going to change my window, and I'm going to adjust my window for the y's, and I want it to go from -1 up to 10. And that'll give me a nicer picture of what's going on with this entire graph. They want the interval. Where is the function increasing, decreasing, and constant? So if we just do this problem from left to right, because again, that's how you determine increasing and decreasing and constant, from left to right. Remember, I plugged in -5 to 5, but it goes on forever. The scale at the bottom is by ones. The scale on the y-axis is ones. So as we're going from left to right on the graph, that means if we're on the graph going from left to right, the y values are headed in this direction. They're coming down. And if I do a trace, it kind of gives you a little visual on this. If I do a trace. So I move the cursor to the left over there, -4, and then I do a trace and I have it go, I'm going to move it to the right. You see how that cursor is moving down. So that means the function is decreasing on that side. From left to right, it's going down, so that means it's decreasing. And it's decreasing all the way from right. Didn't want to zoom in. Not that. And it's decreasing from -infinity all the way down there. And it decreases until we get to this point right there, -1. And the increasing, decreasing intervals are going to be open intervals, right?
No.
Yes, always, always.
Oh,
Okay, unless you have segments with endpoints. We don't have endpoints. When we get to -1 and we go to +1, what is the y value? All the way across. It's always 2. I mean, look at the function. If I go f of 0, absolute value of 0 plus 1 plus absolute value of 0 minus 1. 0 plus 1 is the absolute value of 1. 0 minus 1 is the absolute value of negative 1. Absolute value of 1, 1. Absolute value of negative 1, 1. 1 plus 1, 2. If I get a little bit closer to the 1, so let's move to a half. So if I plug in a half, so 1/2 plus 1 and 1/2 minus 1. 1/2 plus 1 is 1.5. Let's go ahead and go decimal. 1/2 minus 1 is negative 0.5. Absolute value of 1.5 is 1.5. Plus the absolute value of negative 0.5 is positive 0.5. 1.5 plus 0.5, 2. Get even closer to 1, like 0.99, 99 cents. So f of 0.99. 0.99, 0.99 minus 1. So 0.99 plus 1 is $1.99. 99 cents minus $1 is a negative penny. So the absolute value of $1.99, $1.99. The absolute value of a negative penny is a positive penny. $1.99 plus a penny is $2. Every number between -1 to 1 adds up to 2. You do the function. So that means this is decreasing. And then it's constant, because it's always 2, open interval, from -1 to +1. And then if you're on this side of 1, as you go from left to right, the function starts to get bigger, so that interval is increasing. Yeah. Whatever, but from +1 to infinity. So you come up with 3 separate answers for where is it increasing, decreasing, versus constant.
On the -1, wouldn't it be like a plus bracket?
No, because here's the deal. First of all, the directions. Determine the open intervals. Okay? And then here's the thing. It's decreasing here, constant there. How do we know? I mean, technically, as you approach -1 from this side, it's approaching 2. As you approach 2 from this side, it's approaching 2. But it's just continuous at that point. It's different. It's different. 2 different things are happening exactly at 1 and -1. 2 different things are happening. On the left of -1, it's decreasing. To the right of -1, it's constant. So technically, you could have said, all right, at the end of this interval, when you get to -1, it finishes decreasing. There's a solid point there. And at the beginning of -1, it's constant, so there's a solid point there. But that's not how it works. You have decreasing and then constant. It can't be both at the same time. That's why, unless you are specifically asked about closed intervals, or you are specifically given a closed interval, you don't do closed interval for increasing, decreasing, or functions. Okay. That's a real good question, and that's something that does happen in a calculus class. The distinction between the two. But if you're just doing increasing or decreasing in general, it's open intervals. Definition of max and min. Relative. Relative. Back in relatives. Relatively speaking, I am the highest level of education in my family. Relatively speaking. I don't have the highest education, out of everybody, that exists, but in my family, relatively speaking, I have the highest level of education. Now along comes my daughter-in-law, and she joined me. We're now 2 master's degrees in the family. But she has her master's in school psychology. And my son-in-law is now applying for his master's degree in city planning. So we hopefully will soon be going by 3. But relatively speaking, we would all have the maximum level of education. Pomona, Northridge, USC, and Florida. Graduate from Florida. My daughter also. I don't get that. In baseball, you have 3 divisions in each league. You have the East, the Central, and the West. Relatively speaking, you have a winner of each division. Relatively speaking, you have a winner of the East Division, the West Division, and the Central Division. So they're the best records in those divisions. They may not be the best record in all of the divisions, but they're the best record for their little group. So that's a relative maximum because around everybody else, they have the best. Now, the absolute maximum would be the best record in all of baseball. Who has the best for everybody? That's absolute. Now, that absolute usually only occurs if you're dealing with special kinds of functions or closed intervals. We're not talking absolute right now. So it's about increasing use. This is, that song I played for you on Monday. How do you use, when you talk about all the derivative rules, how do we do, when we do a derivative, we find maximums and minimums. Maximums and minimums depend upon increasing and decreasing. A function value f of a. F of a, that's the y value. F of a is called a relative minimum. So the y value is the relative minimum of f when there exists on some interval, x1 and x2, and there's an a on it in between here and here. There's an a in here, such that, of course, we're going to go from left to right. There's an x in here. So that means every single possible x value in here between the left and the right, that y value, f of a, is less than all the other possible y values that this x will generate. If this f of a is smaller than all the other ones, it's your relative minimum. So in other words, mathematically speaking, over here you got x of 1, over here you got x of 2. You have an infinite number of x's here, an infinite number of x's. That's these guys. There is some a in here. If this value right here, f of a, is less than all the other f of x's for all these other x's, if it's below, it could be equal. If it's below all the other ones, that's your relative minimum. Now, they use the word minima because it's plural. Relative min. Relative maximum, and again, relative, because within its surrounding, within its grouping here, this is the highest point you would reach. So you would again have between an x of 1 and somewhere over here an x of 2. For all the x's in between those, there's an a, where that a value, f of a, is bigger than or equal to all the other y values. If it's greater than or equal to, then that has to be the highest point. That's your relative maximum. And again, it's the relative one because relatively speaking, for everything else around it, it is the highest point you would reach. What happens though, because we just talked about increase and decrease, you know you've reached a minimum if a function decreases and then increases. You know you bottomed out. You know you've reached a maximum if a function increases and then decreases, because you know you've hit the top and coming down again. Like a roller coaster. You can see that a function can have more than one relative maximum. Because again, relative in this neighborhood, this is the lowest point for all of these y values. So over here, that's the relative, the bottom, and that's the relative max, or maxima, as we're doing, because that's the highest point for all of those. So in a specific given interval, if the greatest possible y value is your relative maximum, and the smallest possible y value is your relative minimum. Okay. Number 37. Use a graphing utility to graph the function and approximate any relative minimum or relative maximum value of the function. So 37. -2. That's the third. Minus. That's in a second. And then plus 14. Now, again, I have no idea what my, so this right here is the exponent. So when I want to raise something to something other than a square, that's power. I have no idea what the window's going to be like. So if I just use the same window setting that I had before, -5 to 5, and I do my zoom fit. All right, look at this. So right now, my window goes from -5 to +5, counting by ones. And you can see that the relative minimum, the bottom is right about here. That's -2, that's -1, somewhere between -2 and -1. It looks like the relative maximum, the highest point, is right about there. And that's +1, and it looks like +2 is right about there. Okay. I think I need to adjust my window. You see how thick this y-axis is?
Yeah.
Here's why. If I go to the window, look at my y min and y max. I did a zoom fit for -5 to 5. So the calculator generated -205 to +155 on the y-axis. Because it's using -5 in the function. You plug in -5, so -5 to the third is 125. -2 times 125 is -250. -5 squared, or minus -5 squared, so that would be minus another 25. So that's -275. And then plus 14 times -5. So you see where I'm getting. My bad. -2 times -125 is +250. So I guess I just missed that. But either way, that's why the number's so big. I just need to see where the max and mins are. So going back to the picture, I'm gonna readjust. Go back to the picture. It looks like the max and mins are somewhere between here and here. And I certainly don't need -5 to 5 to make that happen. It looks like it's between -2 and 1, -1, 1 and 2. It also might be nice to figure out zeros if they ever ask me. So maybe I want to go from here, -4, because that would allow me to find the 0 if I had to. And over here, that's +3. So I'm going to change my x-axis, my x-min to -4 to +3. Oh, and by the way, the line was so thick because it went from -205 up to 155 and was putting a little hash mark every 1 unit. So it was just thick with all those hash marks. So I'm going to change it to -4. +3. And I'll do a zoom video. Now, it's still pretty thick. But I have a much nicer picture. Let's see what the Y's are now. Y should be a little smaller interval. They go from -21 to +56. So I'm going to change this. Now that's a difference of about 70. I'm just going to change it to, I'll change it to 10. I'll change my Y scale to 10. There we go. That's a lot better. So -20, -10, 10, 20, 30, 40, so on. -1, -2, -3, 1, 2, 3. All right. We're supposed to estimate the relative max and min. So if I'm going to go from left to right, looks like I'm finding the minimum first. That's a relative minimum. And it's certainly fine to just abbreviate min, and then we'll do the relative max next. Now, this question is worded really poorly. When you are asked to find a relative max or a relative min, it's the Y value, just the Y value. What's the highest point? What's the lowest point? What's the maximum the function equals? What's the minimum the function equals? That's what a relative max and min are. Then you could be asked, where does the max or min occur? Or what value of X does the max or min occur? Then you're finding, what does X equal? If you're supposed to find the ordered pair, they should say, find the freaking ordered pair. So when I did this problem yesterday, I just wrote down the Y value because that's the way it's worded. They want the ordered pair. So when in doubt, get your answer, but always check. Always check the back. Do you understand the word? Half of the time, it's not because you did something wrong, it's because you don't understand the word. So here's the deal. Do not do this. If you go trace and you think you're going to estimate the max or min just because you think you're going to hit perfectly that minimum. Now you could, you might, I doubt it. You see how if I'm going, so let me move over here. So as I'm going down the graph, these Y's should be getting smaller because it's decreasing over there. So I'm going to move to the right. I get -14.9, -15, so it's getting smaller. -16, it's still getting smaller. Let's go back. That was -16, so it's still getting smaller. It was 16.4, 16.68, still smaller. 16.8, still smaller. Oops, very 16.82, 16.86, that's still smaller. And now it's getting bigger. Negative 16.79 is higher than negative 16.86. So which one was the minimum? Well, was it this last Y value? I don't know. So that's estimating, sure, but that's not very accurate. If you want to get really accurate, the calculator has buttons. It does it for us, and it's right here under calc. So on the trace button in blue, right above it, is calc. Let me blow this up. So right here above the trace is calc, and to activate calc, you hit second and then calc. And you have all these things. Find the value of the function, find the zero, oh, look at that, find the minimum of a function. So option 3, find the minimum, but look at what you got to do. You have to tell the calculator where to look. So it's asking you left bound. And you know what? I'm going to fix something. I'm going to move my Y window down just a little bit more. Because it's the stuff at the bottom is interfering with the graph. Now when I do a thing, it won't work. So, second, count, and the minimum. So I need to tell the calculator where to look. So I need to move the cursor to the left. I think the minimum is right about here. So I need to move the cursor to the left of it. I mean, left of the possible minimum. So I'm going to move it with the arrows. To the left, 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 to the left. Now, how do I know I'm to the left? Well, you can go all the way to the left if you wanted to. That would be fine. But anywhere on the left, I hit enter. And then it wants the right bound, because you got to give it an interval to look in. So I need to move the cursor somewhere to the right of where the minimum I think is. And I'm going to look to the right, to the right, to the right. Now I hit enter. Now I've never understood this next one. Never. Guess. I don't understand. Do they want me to guess, or do I want the calculator to guess, or I don't know what? So I just hit enter again. And the minimum is right here at x equals negative 1.703259. And y is equal to negative 16.8641. Now, if you were just asked to find what is the relative min, that is the relative minimum of the function, just the y value. In the back of the book, they give you an ordered pair. So negative 17 or negative 1.7. And I think they'll, I don't know, I think they might have done 3 decimals or 4 decimals. 0, 3, 3. And then 4 decimals, negative 16.8641. So that's where the relative minimum is. And now let me show you a little shortcut for the shortcut. Max. It takes a long, not a long time, but it takes some time to move that cursor. Gonna find the maximum. Out. The maximum is option number 4. I believe that my relative maximum is, looks like it's somewhere between 1 and that's definitely 2. But just on the safe side, I'm gonna say like 1/2. So I want the calculator to look between the 1/2 and the 2. So normally I would move the cursor here, hit enter for the left bound, and then move it over here and hit enter for the right bound. Well, you know what? I can just type in 0.5 for my left bound, and it moves the cursor right to that point. And then for the right bound, I hit 2 for the right bound and move it right to that point. And then I hit enter one more time, so it'll take its guess. And the relative maximum. This is my X, this is my Y. So the ordered pair that you're going to see in the back of the book, 1.3699. Comma 12.1604. Well, if I'm going 4 decimal places, that 9 makes that a 4. And if I go 4 decimal places, that 2 leaves that a 9. Now, that's not an interval, that's an actual ordered pair. That's a point because relative maximums and minimums don't occur on intervals. They're specific values. That was 37. All right, 47 is our step function, so we're going to have to pick up there. And I might be doing a little bit of restructuring on the homework for 1, 1, 5, 1, 6, 1, 7, because, you know, my philosophy has always been, I go over homework, no matter what, because I gotta make sure you guys get a chance to ask your questions. And what I've been doing here is I've been going over the homework before you actually do the homework, because a lot of these you've never seen before. I want to make sure you understand what you're doing, not just trying to do the homework and going, I don't know what this problem is. So I want to give you the best opportunity to actually start the homework before you, so you don't just hit a wall, and then you can ask good questions. But because I'm doing so many, it's taking forever. So I think what I need to do is kind of narrow down my focus, and might have to do some adjustments on the other ones. And that's perfectly fine. That's Bobby Brown, my prerogative. You know. Yeah, Whitney Houston's. Yeah, old. I know who's not here. Well, yeah, musician. He's a. Well, I've been around recording.